happens, icing conditions come with it. For your own safety, you need to know when to expect icing and what to do if your aircraft starts icing up in flight. This film presents the information you need to know about helicopter icing hazards. Let's begin with this question. What are the conditions that must occur for ice to form on an aircraft in flight? Not in the engine, but on the aircraft itself. Normally, two things are required. First, there must be visible moisture. Moisture in a form you can actually see, like clouds or rain. And second, the temperature must be at or below freezing. The most common range for icing is between 0 and -10 degrees centigrade. This is where icing most often occurs. Although less common, you can also encounter icing conditions at temperatures below -10, down to -35 degrees. Icing is rare in the colder temperatures. There are fewer clouds because as air gets colder, it can hold less moisture. But caution, if you do encounter clouds at the lower temperatures, the ice may form much faster on your aircraft. So, the two requirements for icing are visible moisture and temperatures between 0 and -35. There's one exception to this rule. If you're flying through moisture-laden air, below clouds, at freezing temperatures, ice can form on the aircraft even though there's no visible moisture. This is uncommon, but it has happened. The hazard of icing differs in each of these ice-producing situations. We'll talk about them one at a time. First, stratiform clouds. Stratiform clouds are made up of minute water droplets or ice crystals. The ice crystals are not the major hazard for you. They will not normally stick to the aircraft. The danger is from water droplets if they have become supercooled. This is a key word in talking about aircraft icing. Let's see what it means. Consider a basin of water that's been standing in a freezer long enough that its temperature is down to -10 degrees. This water is supercooled, below freezing, but still liquid. In this state, any sudden jarring or disturbance will cause the water to freeze instantly. Watch. And that, fellow aviators, is what happens when you fly through supercooled moisture. Your aircraft disturbs the droplets, and they freeze instantly to the aircraft, forming layers of ice as revealed during artificial icing tests. Again, stratiform clouds are characterized by stable air made up of water droplets or ice crystals. If it's water droplets that have become supercooled, you have an icing situation. Cumuliform clouds. The icing situation here is much the same, except that the unstable air with its strong vertical currents may produce much larger and heavier droplets of supercooled water. Looking at just one rotor blade as it turns, we see that these large droplets spread out before freezing. If the cloud has a high moisture content, icing occurs rapidly. For this reason, cumuliform icing presents a greater hazard to the helicopter pilot. Frontal inversions present a particularly hazardous situation. Recall that a frontal inversion involves warm air rising over a layer of colder air. Inversion means upside down. Temperatures increase with altitude as you pass through the inversion. This fact can have an important bearing on your actions in icing, as we'll see later. One type of weather that is unique to inversions is freezing rain. When rain forms in the warm air mass, it falls as liquid drops through the inversion. In the cold air, it may become supercooled. This freezing rain is probably the most dangerous icing condition. It can build a hazardous amount of ice on an aircraft in a few minutes. In winter, the flow of prevailing wind up the sides of mountains causes temperature of the air to drop rapidly. This is one of the common ice-producing situations, especially in the United States. The region of severe icing looks like this, mostly on the windward side of the peaks, and up to about 4,000 feet above the mountaintops, or even higher if the air is unstable. There's one additional icing situation to mention before we leave this topic. If you've been flying in clear air above the freezing level, and then you descend into warmer air that has a high moisture content, some moisture may settle as frost on the cold surfaces of the aircraft, especially on the windscreen. However, this will be brief. The warmer air will soon melt it. Whether you fly VFR or IFR, and no matter how your aircraft is equipped for ice, a major part of safety for cold weather flying comes in the flight planning. There are three essential weather facts you need to determine the icing hazard: the altitude of the freezing level, the clouds and precipitation along your route, and details of the inversion layer if there's a warm front in the area. Oh, and one other as well: any pilot reports that might be available. Obviously, you will want to choose a cruising altitude below the freezing level if possible. But if that's not possible, you're better off being where temperatures are much colder than freezing, preferably colder than minus 35 degrees. However, to do this, you must be able to climb, cruise, and clear of clouds and visible moisture. Remember the caution. If you encounter clouds at very cold temperatures, ice may build up very rapidly on your aircraft. If you're going to be flying in the vicinity of a warm front, you need to find out if the temperatures in the cold air mass are in the ice-producing range. And you need accurate information to define the location and movement of the inversion layer. Should you encounter icing, you will need to know where the freezing level is below you and the approximate altitude of the inversion layer above you. These facts will be crucial to your decision on how to escape from the icing, or better, how not to get into it. You should leave the weather briefing with accurate notes on altitude of the freezing level and details of the inversion layer, if any. But always remember, stay alert for changes. Icing forecasts are, at best, educated guesses. In cold weather, it's very important that you make a careful inspection for frost during your pre-flight. Many pilots make the mistake of thinking that frost doesn't matter, but it does. All frost must be cleared off the aircraft before you attempt to take off. It looks so thin and insignificant, but it adds to drag and reduces lift, and it can get you into deep trouble, especially at the low air speeds of takeoff. Worse, each particle of frost acts like a magnet for the formation of ice. It can lead to a quick ice buildup during takeoff and climb. During operations in cold weather, you must know when to be on the alert for signs of icing. Here, you're flying in clouds, visible moisture. That's one indication. How about temperature? The free air temperature, FAT gauge, reads just slightly above freezing. Fine, except that the FAT gauge is not accurate enough to rely on. It may be as much as 5 degrees in error or even more. So you may be in an icing situation even though the FAT gauge shows above freezing. The key question is, what's the first clue that will tell you if you've begun to gather ice? Often it's right here, torque. Why? That takes a bit of explanation. In a helicopter, often the first thing that begins to ice up is the main rotor. That's because the rotor blades, with their high rotational speed, encounter a far larger volume of air than the fuselage. Icing begins at the root and moves outward. It forms along the leading edge, extending back along both top and bottom, but with somewhat more on the bottom. This rotor blade ice reduces lift and adds drag, which can result in a loss of your auto-rotation capability. Fortunately, before that happens, you normally get a cockpit indication. The loss of lift and increased drag cause your airspeed to fall off. But now, if you're like many helicopter pilots, you correct for that loss of airspeed without even realizing it, by pulling on a little more torque. So the first warning sign you may get is right here. Notice that you're carrying more torque to maintain the same airspeed, it's likely that ice is building up on the rotor. In other conditions, your first indication may be ice that you can see. On the airframe, the buildup begins on the windscreen, wiper blades, or other projecting surfaces. What action should you now take? The answer depends on whether you're in clouds or in freezing rain. If you encounter icing in clouds, descend to an altitude clear of the clouds or below the freezing level. If any ice remains on the aircraft, continue the descent and land. As mentioned earlier, some instances have been recorded of icing in moist air beneath clouds. If you encounter this situation, and it requires an appreciable increase of torque to maintain airspeed, descend and land. Now, suppose you're flying in the vicinity of an inversion layer and you start running into freezing rain. If the freezing level is at the surface, you should probably not attempt a landing. Depending on the circumstances, your best bet may be to climb through the inversion layer into the warmer air above. Freezing rain is the most hazardous of all icing situations. The ice can build up very quickly. That's why it's vital to know where the freezing level is and where the inversion layer is. One further precaution. If you return to your field with ice on your rotor blades, all personnel must be warned to keep well clear until your rotor has stopped. Ice thrown from a turning blade can be very bad for your health. This strange-looking arrangement is part of a research program. One step in the development of an ice-flying capability for Army helicopters. Attached beneath the lead aircraft is a rig that puts a spray of water into frigid air. The other aircraft flies in the spray, and measurements are taken as ice builds on it. Slow-motion photography clearly shows the ice on the rotor blades of this Chinook. The tests demonstrated why icing of the tail rotor is not a problem on some helicopters. If you look closely here, you can see the reason. Exhaust from the engine swirls back past the tail area and keeps it warm. These tests brought a better understanding of what is called asymmetrical shedding. That 10-gallon phrase simply means that a hunk of ice flies off one rotor blade, leaving the rotor severely out of balance. Watch. Again, this time from a Huey. The flying hunks of ice can cause damage to the rotors, airframe, or turbine blades. But the real problem is vibration, which can become very severe. There may come a time when you find yourself flying in icing conditions, ice building up on the aircraft. The experience of other pilots has demonstrated that you will have time to recover safely. As with any aircraft emergency, panic is your worst enemy. Protect yourself. Learn the weather characteristics of icing. Know the weather you're flying in. Study the recovery procedures. There's always ice in some part of the world. Until new developments give us the capability to fly through it, we have to learn to live with it.